Section 4 of Canadian Electrical Code 4-004, ampacity of wires and cables, sizing, ampacity calculations or sizing cables, whatever you want to call them, just feels so difficult. So I tried to simplify it for you into this chart. So let's take a look at this little squiggly chart. I hope gives you a quick picture of all we're doing here. It's actually pretty simple. You're either working with copper or you're working with aluminum. If you're working with copper, you're going to use tables 1 and 2. If you're going to work with aluminum, you're going to use tables 3 and 4. Tables 1, 2, 3, and 4 pretty much do the same thing. All tables 1, 2, 3, and 4 do is they have 3 variables, basically. So it's a table with, across the top is, what's across the top? Insulation temperature. Down the side is your gauge, your wire gauge size, and in the middle is your ampacity. So if you know what gauge of wire you're working with and which insulation temperature you're working with, you can find the ampacity, or the amount of current that you're allowed to run on that size of wire for that insulation temperature. So it's your maximum current. You would use table 1 and table 3 if your installation is in free air. You would use table 2 and table 4 if you're installed in a raceway or something else that is constricted, like inside cable. So copper is table 1 and 2 for free air and raceway. Aluminum is table 3 and 4 for free air and raceway. That's all. But then you take that current, and sometimes it's not good enough, because table 1, 2, and 3, 4 are for environments up to 30 degrees Celsius, ambient air. Ambient air is the air around your installation. So if you're installing this in a hot environment over 30 degrees, then you just put a correction factor of 5A. You can put that on aluminum and copper. Your values from table 1, 2, 3, and 4 get corrected by 5A for any ambient temperature over 30 degrees. But sometimes you are running more conductors than what are listed in table 1, 2, 3, and 4. All right, so table 1, 2, 3, and 4, if you're running more conductors, then you'll go to table 5B for running more conductors in free air, and you're going to go to table 5C for running more conductors in raceway or cable. So that's really it. You're seeing, do I have copper? Do I have aluminum? If I have copper, I go to table 1 and table 2. I know my size. I know my temperature from the type of cable I'm using, because it's a rated insulation temperature on there, and I get my ampacity or my current. That current needs to be derated if I'm going to install in a ambient temperature over 30 degrees. I derate with factor 5A, whether I used table 1 and 2 for copper or 3 and 4 for aluminum. If I'm running more conductors than what are covered in table 1, 2, 3, and 4, I'm going to use 5B and 5C to derate that even further. So let's look at what this looks like in the code. So in the code, it looks a little bit more complicated. Here's section 4. Here's 4-004. I'm highlighting it for copper right now. And the second section is for aluminum. And so what we should note here is that really I'm only talking about subsections A, B, and C of section 1 of 404 and of section 2 of 404 for aluminum. If you look at D, E, and F, those are all for underground installations. So we'll talk about that at a different day. So basically, single conductor and single conductor metal sheets or armor cable in a free air run goes to table 1. So let's look at what table 1 looks like. Table 1, we are in free air. We're up to 30 degrees Celsius. If I know what I'm working with, for example, a 90-degree rated type of insulation, and let's say I'm working with 8 gauge wire, then I can put 80 amps in that circuit. But that's only if it's in 30 degrees. Let's say it's higher than 30. Let's say it's 50 degrees. So this starts at 35. This chart, let's say it's 50 degrees. Again, I have to go to that 90 because I'm working with like an insulation that, a cable that has maximum insulation temperature of 90. So now I need to multiply 0.82, this factor in this table, 0.82 here, to my 80 amps. So of course, now I can use less than 80 amps, which makes sense because it's a hotter environment, harder to dissipate heat. Then I go back to table 1 and I look at 5B. 5B says, Well, if you're running two conductors, actually, not just that one conductor in that free space, or three conductors or four conductors, I need to derate it even further because each of those conductors is going to be dissipating its space. And the spacing is important, right? They have to be a space. For this, it's spaced less than 25% of the largest cable diameter. So they're pretty tightly spaced together. So because of that heat from the extra cables, you're going to have to derate it more. So for example, if I have three conductors, I derate it with this rating factor, which is 0.85. So in my example that I just gave you, I would have 80 amps and I would have to multiply that by 0.82 because of the ambient air temperature correction, and then 0.85 because of running three conductors in that free space. So it's not that difficult. It just kind of looks difficult in the electrical code because you have to click all over the place and apply lots of factors. So I hope that this little flowchart simplifies things for you. You go to table 1, 2, 3, and 4, correction factor for ambient air and correction factor for the number of conductors. And that's it. Thanks for watching. If you want to quiz yourself on this material, look at my quizzes where I give you all of the solutions. You can pause me and do them yourself, or you can unmute me and I will walk you through example problems of 4-004 ampacity calculations. Best of luck.